In this video, we're going to learn about the algebra of functions, which means we're going to learn how to add, subtract, multiply, divide, and compose functions. I'd like to take a look at an example of each. So in this first example, we have let f of x equal 2x squared plus 3x and g of x equal x minus 2. And we want to find h of x if, and in part A, if we add f of x and g of x. In part B, f of x minus g of x. Part C, we're going to do f of x times g of x. And part D, we're going to do f of x divided by g of x. And I'm going to simplify each as much as possible. So for part A, we want to add them. So we're going to have h of x is equal to f of x, which is 2x squared plus 3x plus x minus 2. And I'm putting x minus 2 in parentheses just out of habit because when we subtract, we want to make sure we distribute the negative to both terms. Well, in this case, by distributing the positive to both terms, we get the same sign that's out in front of the terms already. So here, when I simplify, I have 2x squared, and now I have a 3x plus an x, so I get a 4x minus 2. In part B, we want to do f of x minus g of x. So we're going to have 2x squared plus 3x minus x minus 2. And now when we simplify, the only x squared term is the 2x squared. And now we have 3x minus x, so we get plus 2x. And now we have minus a minus 2, so we get plus 2. For part C, we want to multiply the two together. So we have h of x is equal to 2x squared plus 3x times x minus 2. And now we'll multiply this out. So first terms, we have 2x squared times x, giving us 2x cubed. And then we have 2x squared times negative 2, or minus 4x squared. And then we have inner terms are 3x times x, 3x squared. And the last term is 3x minus 2, giving us minus 6x. And now we can combine x squared terms. So we'll have 2x cubed minus x squared minus 6x. In part D, we want f of x divided by g of x. So we get f of x up top, 2x squared plus 3x divided by x minus 2. And there's no simplification we can do for this one. So that's how we add, subtract, multiply, and divide functions by each other. And in this next example, I want to take a look at compositions. So we have let f of x equal 3x squared plus 6x, and g of x is equal to 2x. And we want to find f composed of g and g composed of f. So for part A, we have f composed of g. And remember that that is the same as writing it like this. And I prefer to write it the second way just because I can see which function I'm putting inside the other function. So what this means is we're going to take the g function and put it inside the f function. So everywhere where there's an x in f of x, we're going to put the g of x function. So we have 3 times, now we have an x, so we're going to put 2x in its place, 2x squared plus 6 times 2x. And now we simplify. So we have 3 times, now when we square 2 we get 4, and x squared plus 12x. And then 3 times 4 is 12, so it simplifies to 12x squared plus 12x. And for part B, we want to do g composed of f, or g f of x, which is equal to 2 and we have an x, so where this x is, we're going to place this entire f of x function. So we have 2 times 3x squared plus 6x, which equals 6x squared plus 12x. And the last example is f of x is equal to x squared minus 2x, and we want to find f of x plus h, and then we want to find f of x plus h minus f of x, all divided by h. So just like in the compositions where we inputted one function into another, this one's going to work similar. Everywhere where we see an x in the function, we're going to place an x plus h. So for part A, f of x plus h is equal to, we have x plus h squared minus 2 times x plus h. And now we'll simplify. X plus h squared works out to be x squared plus 2xh plus h squared. And then we're going to distribute this negative 2 to both terms. So minus 2x minus 2h. And now in part B, we're going to find f of x plus h, which is what we just found, minus f of x divided by h. And then we're going to simplify it. So here, I'm going to start by rewriting everything we found for f of x plus h. So we have x squared plus 2xh plus h squared minus 2x minus 2h, and now minus f of x, x squared minus 2x, all divided by h. And when we do this, we can see that our x squared terms cancel. We have a positive x squared in the first term, and then we have a minus x squared. So that x squared cancels with this x squared. And then I have a minus 2x here, and minus a minus 2x, which is a positive 2x. So this term cancels. And what I'm left with is 2xh plus h squared minus 2h, all divided by h. And now I'm going to factor an h out of the top. So I'm going to have h times 2x plus h minus 2 divided by h. And now my h's cancel. So I'm left with 2x plus h minus 2. And that's all for the algebra of functions.